Hi, welcome to Learning Monkey. I am Vikram. In this class, we'll try to understand identification, MF, and fragment offsets. So these are the fields of IPv4 header. So some of the fields of IPv4 header has already been discussed in our previous videos, and the concepts related to the discussion about these fields has already been discussed in our previous video. If you haven't watched that video, please watch that video, because without understanding the concept that we have discussed in the previous video, you may not be able to understand anything from this video. So please try to watch that video and come back here. And every video in our channel is going to be part of entire course or a playlist. Our suggestion is to follow the entire course so that you can have better understanding of the concepts, and the link for the playlist is provided in the description below. Now coming to this class, identification, MF, and fragment offsets. So these are the fields in the second row of the IPv header. So these are the fields in this second row. The fields in this second row we are going to discuss in this class. We are going to discuss about identification, and next is MF. MF stands for more fragments, and the next one is fragment offset. So about DF we will try to understand in our next class. So what is this fragment offset? Fragment offset is the number of data bits ahead of the fragment. So we will try to understand about this definition by considering our example. In our example, when we discuss about the concept, then we will try to understand. So this is the real world example. Using this example, we are going to understand how those fields will help us in the communication. So in the transfer of data from source to destination. Okay, efficient transfer of data from source to destination. So let's consider this network, and in this network we are having this network. This network is having an MT of 500 bytes, and this network is having an MT of 300 bytes. And the actual data that has been transmitted by the application layer is 1000 bytes. Assume that the data that has been transferred by system A is 1000 bytes of data. Now as we have discussed, so this is application layer, and this data will be transferred to the transport layer, and here in the transport layer, to the data that has been transmitted, this is the message or data, to that the transport layer bytes will get added. So transport layer bytes will get added. Transport layer header will get added, which is of size 20 bytes. So it becomes 1020 bytes of data, including the header. So what happens here in the diagrammatic representation is, it is 20 bytes will get added, and this is transport header, and the actual data is 1000 bytes. But as we have discussed that the networks below it, or the layers below it, may not be having the capacity to transfer the data that has been transferred by the application layer. So the transport layer is going to decide which is the smallest one. Based upon that, the division of this packet, the segmentation is done at the sender. At the sender, the segmentation happens. The fragmentation happens at the router. That also we will try to understand. So this packet, this size of data will get transferred to the network layer, and the data link layer capacity is, our capacity at the data link layer is 500 bytes. Being 500 bytes, the network layer, so and the network layer capacity is 65,535. so this is very larger capacity, network layer capacity, but this 1020 bytes of data cannot be transmitted through the data link layer. The data link layer is having, the underlying network is having a capacity of only 500 bytes. So now this entire packet of 1020 has to be divided based upon this concept. So how that can be done? As we are having 500 bytes, so the network layer, at the network layer, how this, on what basis this pieces has to be done? Because the network layer header is going to have 20 bytes, and as it is a capacity of 500 bytes, so 480 bytes should be the data bytes. So this is how the network layer header, right? 480 should be the network layer data, and to that 20 bytes of data will get added as the header. Now how the division is done? So considering this big this in the biggest form, okay, 20 bytes of transport header. Okay, this piece I am taking here, and this is 1000 bytes. So how the division has to be done? Starting from here, including the transport here, starting from here, we have to take the first 480 bytes. First 480 bytes. This is our first piece. So how many pieces will this 1020 has to be divided so that it can be transmitted into the data link layer? It is 1020 divided by 500, which is around sorry, it is 3 pieces, I think so. Okay, 3, it is 2 point something, 2.7 or 8 we are going to get, and 2.1 I think, and 2.1 is not possible, so we have to divide it into 3 pieces. Okay, so the first piece, every piece should have data bytes of 480 bytes, and the second piece will also have 480 bytes. As we are having 1020 first piece and second piece, combining this we are going to have 960, and the remaining is how many bytes? 960, 40 plus 20, this is 60 bytes. Okay, so the 60 bytes is the last piece of data. Now these data bytes will be transferred to the network layer. That segmentation is done at the transport layer. Now these pieces of data will be transferred to the network layer, and how that is going to be done? What happens at the network layer? The first piece is, so let's, okay, so the first piece is, what is our first piece? 480 bytes of data. Because it is the first piece, the 460 bytes of data is, see here, the 20 bytes of transport header is included in the first piece. The 20 bytes of transport header is included in the first piece. So the remaining, this 460 bytes is the data bytes, and this is getting transferred to the network layer. To this 20 bytes of network layer header will get added, and the second piece is 480 bytes of data. This part, 480 bytes of actual data, and to that network layer header of 20 bytes will get added. And the third piece is of 60 bytes, and to this 20 bytes of network layer header will get added. So this is how this is the 3 pieces that we are going to get at the network layer. Now these 3 pieces, so the what is this? So the identification. So here what the second row of the network layer fields will get filled with. That is very important to understand. Here, as these packets are transmitted continuously into the network, these 3 packets are transmitted into the network. If it is a datagram network, so they will get distributed, and each packet has to be identified uniquely. So how we are going to identify that this packet of data is from this source, and this packet is also from the same source at the destination? How it is going to identify? So that identification is done by the number called identification number. See here, in these fields, in the network header fields, the identification field is having 16 bits. So each and every fragment that we have divided the entire packet into, each fragment is given an ID, and that ID, assume that the ID is 80. Let's assume that the ID is 80. So all the fragments of the packet, all the fragments of the same packet will be provided with the same ID. So by seeing this ID, what the destination will identify, that all these fragments with the source IP address, it is going to identify that this fragments has been arrived from this source, and all these fragments are having the same ID, which means that all this, by combining all this, we can get the original packet. So this is how the decisions can be made. And what about MF? MF means more fragments. So as a packet has been arrived at the destination, how the destination will know that? So there are more destination or router. So how the router or the destination will know that there are more fragments that are to be arrived at to me. So how the decision can be made is by using this MF bit. So in the network header we are having a bit 1 bit space for MF, more fragments. If this MF bit is set as 1, which means that there are more fragments that are following. So for example, if you take this fragment to this fragment is following, right? And to this fragment is following, and to this fragment any other data fragments that are following? No. So for this fragment in the network header, the MF bit will be set to 0, and for this it is set to 1 because this fragment is following this fragment. So this is set to 1. Okay. Next one is fragment offset. So for example, if these data bytes are transmitted into the network and the interconnections of the routers, it is a datagram approach, connectionless approach. So the packets will be distributed in a random way. If in that case at the destination, how we are going to identify that they are in the order? So that is identified by using this fragment offset. So what is this fragment offset is? The definition has been explained in the above. Fragment offset is the number of data bytes ahead of the fragment. If you consider a fragment, ahead of that fragment, how many number of data bytes are there? That gives the fragment offset number. So how we are going to get that? Let's see here. Okay. So to this data fragment, are there any data bytes ahead? Are there any fragments ahead? No, there are no fragments. So there are no data bits also. So the fragment number for this fragment is the fragment offset that will get assigned in the network header of this fragment is 0. And if you come here, how many data bits are there? Ahead of this fragment? It is 480. So the network, the transport header is also part of the data. But for better understanding, I have written it here. This is transport header, which is part of the data, and this is network header. So I am stressing this point again and again to get the clarity. So the number of data bits ahead of this fragment, it is 480, and if you take this, the number of data bits ahead to this fragment is 480 plus 480, which is 960. This is the fragment offset that is allocated within this network header. Okay, so why this fragment header has been taken in this way, that we will try to understand slowly. So in the other part of this video. Okay, now all this is done at the sender. Now these three packets will get transmitted into the network, and it will get received at the router. So first packet, second packet, third packet, all this packet has been received at the router. Now what the router will do? So it will fetch all those packets, and it will fetch all those packets, and now it has to send it through an interface so that it has to reach to the destination B. Okay, now what is the maximum transmission unit? The maximum transmission unit of this network is 300 bytes, but the actual packet that has been arrived at the router is of size 500 bytes. So how that can be? So 500 means it is 480 bytes. Okay, the network layer header will be removed, and to that the new network layer header will get added. So how that can be done? So let's try to understand that. So again, the fragmentation, here the router will do the fragmentation. So far at the sender, the transport layer, the segmentation is done at the transport layer. Within that, based upon the capacity of the network or based upon the ability of the network layer, it is going to make the decision and the pieces are made. Now here that all these packets has been transmitted, and the router now it is going to do the fragmentation. So how that fragmentation is done? So let's again write we will take the content, so we'll freshly do that. So here how many packets has been received? The third packet is 60 and 20. The second packet is 480 and 20, and the first packet is 480 and 20. So I am not going to give the representation of a transport header here, and the identification number is 80 for all these packets, 80. Okay, and the MF bits are 110, no fragments following, and the fragment offset is 0, 480, and this is 960. Okay, now at the router, this packet has to be divided again into small pieces. So how that fragmentation is done? See here, the capacity of the underlying network is 300 bytes, but we have received a data of 480, and the network layer, it should have 280 bytes of data and 20 bytes for network layer header. So this piece of data, this piece of 480 bytes of data has to be divided into such a way so that the first fragment should have every piece of data should be 280 bytes. So this has to be divided. This has to be divided in such a way so that each piece should be 280 bytes. And as we are having 280, and the remaining part is going to be 200. And similarly, if you take, from here, this is 280, this is 280, and this is 200. As it is less than 280, so this one will be taken into one packet itself. So further divisions are not possible, will not be made for this packet, 280 and 200. So how many packets the entire content has been divided into? It is 280 and 20. Again, because this is the first one, 260 is the actual data, and this is transport layer header, and to that the network header has been added. So again I am stressing it, transport header. And the second packet, it is 200, and this is 20 bytes of data. And coming to this packet, again third packet, it is 20 bytes of data, 280. And fourth piece is 200 bytes, and to that network layer header. Okay, and this one 60 and the network layer header. New network layer, this one will be discarded, this one will be discarded, and this one will be discarded. To that new network layer header will get added with the change in values. What values will get changed? Will the ID changes? No, the ID will not change. Whatever and how many fragments you do for the given packet, the ID for that should not change. It should remain 80 itself. The next one is MF. How the MF will get reflected? So the MF for the first packet is 1. It means that there are some packets which are following. So if the parent packet fragment MF is 1 means, so for the remaining childs also, the fragments that we have done, so the fragments that we have done, to all those fragments the MF should be 1. For example, so this fragment has been divided into 2 pieces, and the MF for this is 1. MF for this one is 1 because this is following, and we should not give it as 0. MF should not be given as 0 because the parent is, this is the parent, right? This has been divided into 2 pieces. As the parent MF is 1, So the fragments into the number of fragments this parent has been divided into, so each fragment should have an MF of 1. Why? Because if we give 0 means it means that there are no fragments that are following, but this is stating that this MF is equal to 1, stating that there are some fragments that are following. So if you assign it as 0 means if the parent MF is 1 means the fragments that we have made that parent into, all those fragments should be given an MF of 1, because there are some fragments that are following this fragment. So this one should also be 1. Okay, and again the MF is 1 because the parent is 1, this has to be. If the parent is 0, then the condition is, if that parent with 0 MF is divided into fragments, all the fragments are to be given an MF of 1, but the last fragment should be given an MF of 0. It means that further there are no divisions. As we haven't divided this fragment into pieces, so we have to mention that fragment, the MF for that fragment should be 0. If there are no divisions, the MF should be 0. There is some logical explanation. So just blindly don't believe that the last if the parent MF is 0 means we have to give it is 0. If this last fragment, if the MF is 0 means it is going to be the last fragment. If that last fragment is having 0 means, and if it is not divided into fragments further means, so it should be given as 0. If it is divided into fragments, then all the fragments should be given an MF of 1 and the last fragment should be given an MF of 0. It means that further no fragment is following. Okay, so for that clarification we have given it as 0. The next very field that we have to understand is fragment offset. So the fragment offset, so the same definition applies. Are there any data items that are ahead of it? No, so we have to take it as 0. So here in between these two, see here the first fragment offset is 0 and after that it is 480. So try to get that point. So between these two, how the fragments has been divided, the fragment offset has been set, that we will try to understand. So if you take this, so are there any fragments ahead of it, the data bytes ahead of it? Yes, there are data bits. It is 280. Okay, so the number of data bits that are ahead of it is, including this transport header, it is 280. For example, if you take this, are there any? Yes, there are. It is 480. Again, see here. How many fragments that we make in between the two fragments? Two basic initial fragments, they will never going to be equal to the fragments that are in between. So that is the use of this fragment offset by considering that definition. So based upon the definition of, are there any data heads ahead? If there are data heads, then those many data heads, adding those many number of data heads should be given as the fragment offset. Okay, so now the next one, are there any data heads ahead? Yes, 480 plus 280, it is 0, 16, 760. Are there any data heads ahead? Yes. How many are there? It is plus 60, plus 200. It is 960. See here, 960, the last one. Okay. So this is how the ID, MF and the fragment offset will be set at every fragmentation that is done at the routers or at the segmentation. Okay, the point you have to understand here is how the identification field, MF field and the fragment offset field will get set at every router where the fragmentation is done. Okay, so hope you got the clarity on this concept. Thanks for watching. If you haven't subscribed to our channel, please subscribe to our channel and press bell icon for the latest updates. And if you have any doubts regarding this concept, please post your doubt in the comment section below. And if you feel that this video is helpful to you, please give us a like symbol and please share this video with your friends so that they will also get benefited. Thanks for watching.